Look up at the night sky tonight. Everything you see is smaller than this. Far smaller, almost laughably so. Beyond the stars, something enormous waits. Something astronomers struggle to even describe. It stretches across distances your mind cannot hold. Light itself takes ages to cross it, and it should not exist at all. Our best theories say structures this big are impossible. Yet there it is, hanging in the dark. To understand it, we must first shrink ourselves. Earth is a pale blue dot lost in sunlight. Now zoom out further, past the planets. Our entire solar system becomes a single faint speck. Keep going outward, the sun joins billions of other stars. This is the Milky Way, our home galaxy, a glowing spiral 100,000 light-years wide. But the Milky Way is just one galaxy. The universe holds perhaps 2 trillion more like it. Galaxies are not scattered randomly through space. They gather, drawn together by patient, relentless gravity. Small groups form first, just a handful of galaxies. Our Milky Way belongs to one called the local group. The local group contains around 80 known galaxies. Most are tiny dwarfs orbiting larger neighbors. Zoom out again, and the local group shrinks. It becomes a single dot inside something larger. That larger thing is called a galaxy cluster. Clusters can hold hundreds or thousands of galaxies. And clusters themselves gather into superclusters. These are some of the biggest structures we know. Our home supercluster is called Laniakea. The name means immeasurable heaven in Hawaiian. Laniakea contains roughly 100,000 galaxies. It stretches over 500 million light-years across. That number alone should already feel impossible. Light, the fastest thing in existence, takes that long. But Laniakea is not the largest, not even close to what we found later. Across the universe, astronomers began mapping galaxies, patiently, patch by patch, decade by decade. What emerged was unexpected. Galaxies trace delicate, glowing filaments through the dark. Between the filaments lay enormous empty voids, bubbles of almost nothing, hundreds of millions of light-years wide. This pattern has a name. Scientists call it the cosmic web. The cosmic web is the skeleton of the universe. Gravity sculpted it from the faintest early ripples. Along these threads, the biggest structures form, and one of them broke every expectation we had. In 2013, astronomers spotted something strange, a pattern of distant, bright gamma-ray bursts. These bursts mark the deaths of massive stars. Each one briefly outshines an entire galaxy. Their positions seemed unusually clustered together, far more than random chance should allow. When mapped, the cluster revealed a vast structure. It became known as the Hercules-Corona Borealis Great Wall. The name is long. The object is longer still. Imagine a sheet of galaxies, not a clump. A wall draped across the distant cosmos. Estimates suggest it spans about 10 billion light-years, roughly a tenth of the observable universe itself. Take a breath here. That number does not behave normally. Light leaving one end would need 10 billion years just to reach the other side of the wall. Nothing in the universe moves faster than light, yet light itself feels slow against this object. A photon born at one edge, but arrive aged, nearly the entire history of time burned away in transit. That is nearly the age of the universe itself. The structure is almost as old as time. Here is where your brain begins to slip. Modern cosmology has a rule called homogeneity. The rule says the universe should look uniform. On large enough scales, no clumps should dominate. Theoretical models suggest a limit around 1 billion light-years. Beyond that, no single structure should hold together. Yet the Hercules wall is about 10 times bigger, 10 times beyond what the rules seem to allow. Think of it like finding a continent on a marble. The proportions simply do not match the model. If the measurements hold, our models are incomplete. Something about the early universe is missing from them. Some astronomers remain cautious about the claim. They wonder if it might be a statistical mirage. The galaxies could simply appear aligned by chance, like seeing faces in scattered clouds at sunset. Other surveys, though, have found similar giants. walls and arcs that also seem too large. One is called the Giant Arc, discovered recently. It stretches across roughly 3 billion light-years of space. Another, the Sloan Great Wall, spans over 1 billion. Each one quietly challenges the cosmic rulebook. A newer structure, the Big Ring, was also spotted. A vast ring-like pattern, billions of light-years across. These discoveries are not isolated curiosities anymore. They form a quiet, growing pattern of cosmic unease. So even if Hercules is contested, the puzzle remains. The universe keeps building things it should not. Pause for a moment and picture this honestly. You are made of atoms, sitting on a planet. Your planet orbits one ordinary star. That star drifts inside a spiral galaxy. Your galaxy sits inside a cluster of galaxies. The cluster floats inside a vast supercluster of clusters. The supercluster threads into the cosmic web, and somewhere in that web hangs a wall. A wall, 10 billion light-years across, made of galaxies, each holding billions of stars. Every one of those galaxies could host living worlds, planets, oceans, perhaps eyes turned toward their own skies. We will never meet them, never even see them clearly, yet they share the same enormous, unfinished story. If you could see one cosmic giant with your own eyes, which would it be? Tell me below. Now, how do astronomers even detect such things? They cannot photograph the wall directly, not really. Instead, they map the positions of countless galaxies. Gamma-ray bursts act like distant lighthouses in the dark. Each burst marks a galaxy that briefly screamed. Its light traveled billions of years to reach us. By plotting bursts in 3 dimensions, patterns emerge. Clumps, threads, and walls slowly take shape on screen. It is a kind of cosmic dot-to-dot puzzle, drawn across billions of years and billions of light-years. The Hercules-Corona Borealis wall appeared this way, a faint overdensity hidden inside vast cosmic noise. It is less a solid object than a region, a volume where galaxies cluster more than expected. But that distinction does not shrink it. The scale, the gravity, the implications all remain enormous. There is another twist worth holding gently. We see the wall as it was long ago. Its light left when the universe was younger, smaller, hotter, and still rapidly evolving in many ways. So, this giant existed surprisingly early in cosmic history. Massive structures had less time to form back then. That makes its size even harder to explain. Gravity needs time to gather galaxies into walls. Either the early universe was lumpier than thought, or our timeline of structure growth needs serious revising. Both options are quietly revolutionary in their own way. Either rewrites part of the cosmological story we tell. This is why honest scientists love these puzzles. A mystery this big invites sharper, better questions. Some researchers suspect dark matter plays a key role. Its invisible gravity scaffolds the visible cosmic web. Others wonder about the earliest moments after the Big Bang, tiny quantum ripples stretched into colossal structures. Inflation theory describes that violent early stretching, a sudden expansion faster than light could travel. In a fraction of a second, the cosmos ballooned, from smaller than an atom to astronomical scales. Those ripples became the seeds of every galaxy, and perhaps the seeds of every great wall, too. The largest object in the universe may have started microscopic, a whisper blown up into something staggering. That idea is almost poetic if you let it land. The biggest thing began as the smallest possible thing. Step back and feel the scale once more. Our planet 8,000 miles across feels huge. The sun could swallow 1,000,000 Earths inside it, yet the sun is a pinprick in the galaxy. The Milky Way holds hundreds of billions of suns, and it would vanish inside the Hercules wall. You could line up 100,000 Milky Ways, they would still not quite span its length. Numbers like these stop feeling like numbers. They start feeling like a kind of quiet music. The ear cannot hear it, of course, but something in the imagination begins to hum along. Maybe that is the real gift of these structures. They remind us how small our usual scale is. A traffic jam, a deadline, a worry, a fear, all real yet placed against galactic walls, softer. Not meaningless, simply held inside a larger frame. The cosmos does not erase us, it widens us. Astronomers will keep testing the Great Wall claim. New surveys map deeper, sharper slices of sky. Telescopes like Euclid and the Vera Rubin Observatory help. They will chart billions of galaxies in coming years. The James Webb Space Telescope adds another set of eyes. It peers back toward the universe's earliest light. Each new instrument is a kind of time machine. Looking deeper into space means looking deeper into history. If the wall is real, its details will sharpen. If it is a mirage, the mirage will fade. Either outcome teaches us something profound about reality. Science wins quietly. Either way, the data falls. And other giants almost certainly wait undiscovered. The observable universe is about 93 billion light-years wide. We have only mapped small fractions in true detail. The deep field still hides countless secrets from us. Somewhere out there, another wall may be forming, galaxies drifting together along threads we cannot yet see. Light from those regions has not even reached us. We may never witness some of it, ever. That thought is humbling, but not really sad. It means the universe is generous beyond our reach. Imagine future astronomers centuries from now, with sharper tools. They will see structures we can only guess at today. Perhaps they will confirm the Hercules wall completely. Perhaps they will replace it with something even larger. Either way, the lineage of wonder will continue. Every generation widens the map of the cosmos. So tonight, when you step outside and glance up, remember what hides beyond those familiar twinkling points. Beyond the stars, the galaxies wait quietly. Beyond the galaxies, the clusters drift in slow dance. Beyond the clusters, the cosmic web of light glows, and woven into it, walls older than almost everything else. You are a brief spark inside that vast architecture, conscious matter looking back at its own scaffolding. That alone may be the strangest fact of all. The universe built something capable of imagining itself. We are how the cosmos opens its eyes, a flicker of attention inside an ocean of silent structure. Every question you ask about the universe matters, even the small ones, even the ones without answers. Curiosity is its own kind of cosmic event, a tiny mind expanding to meet a vast one. The wall does not know we exist out here, but we know it exists, and that is everything. That asymmetry is the quiet miracle of being human. Brief, fragile, yet somehow able to comprehend giants. If this journey stretched your mind, leave a comment. Tell me which scale shook you the most tonight. Subscribe and ring the bell for more journeys into the cosmos. The deep field has many more wonders ahead. And remember this, the next clear night you look up, the largest thing you cannot see is still watching back.